All right, so the back side of this, again, is kind of death by equation. So we have 6 more problems, and all but one of them requires use of equations. So let's go. Mrs. Bailey has an equal number of nickels and quarters. So we have nickels and quarters. We have no dimes, no pennies. And the value of the quarters is 180 more than the value of the nickels. So we have to pull that out, know that that's going to be an issue. What is the total value of all coins together in dollars and nickels? So she has an equal number of nickels and quarters. So we know that nickels equals quarters. And then we also know that the quarters are going to be worth more than the nickels. How much more? $1.80. Now here's the thing. If N and Q are respectively the number of nickels and Q is the number of quarters, well, how do you figure out how much money you have in quarters? How much is a quarter worth? A quarter is worth 25 cents. So that means 0.25 Q is equal to, because every quarter is worth 25 cents, so you multiply the number of quarters times 25 cents, and you get how much you have in quarters. And then for nickels, how much is a nickel worth? That's right, 5 cents. So we have 0.05 times the number of nickels you have, that'll give you the number of nickels, plus the $1.80, and that would equal how much you have in quarters. Now, I don't know about you, but I'd rather not have to deal with decimals. So what can I do? Let's, instead of working in decimals or working in cents or dollars, let's work in cents. So let's multiply everything by 100 because there are 100 cents in a dollar, right? So really we have 25 cents per quarter and we have 5 cents per nickel, and that means the nickels need to have 180 cents added to them to equal the number of quarters. But wait a second. We know that nickels and quarters are equal. So couldn't I also, instead of using the Q, what's another way of saying Q? Quarter. N, because nickels and quarters are the same. So I'm substituting N for Q because they're equal. So 25 times N is equal to 5N plus 180. Now here's the tricky thing. I haven't spent much time with you, any time really, in solving equations, but I guess now's the time. Equations are kind of like a seesaw, where they balance on the equal sign. So one side is equal to the other side. And I'm guessing you've seen this with Mrs. Frank. So the rules in solving equations, rules, why do you have rules? It's a game, really. So think of solving equations like a game. And you win the game when you get the variable, also known as the letter, all by itself on one side of the equal sign. The rules in the game are you can add, subtract, divide, or multiply anything you want to one side of the equal sign as long as you do the exact same thing to the other side of the equal sign. And what I like to do in 7th grade is I have kids draw this fence. Sometimes they call it train tracks, and actually they've been called Framkels because they're my invention. Anyways, so you draw so if I say train tracks, that's what it is. So I draw the lines to designate the two sides of the equal sign. And so I want to get the ends on one side of the equal sign. And to move things from one side of the equation to the other side, I have to do the opposite. What's the opposite of positive 5n?
Negative 5n?
That's right. So we're going to subtract 5n from both sides. So if I have 25 n's and I take 5 of the n's away, I'm left with 20 n's. 5n minus 5n is 0. I've done nothing with the 180. And so now I'm multiplying 20 times n. Now I've skirted around this issue in a lot of videos, but I'm tired of that. since I told you the rules, we can add, subtract, divide, or multiply anything we want to one side as long as we do the same to the other. We want to get this n by itself. What is the opposite of multiplying n by 20? The opposite of multiplying is
no, dividing.
Divide. Oh my goodness. So we're going to divide both sides by 20. So that means we have 9 nickels. Well, if we have 9 nickels, how many quarters do we have? 9 quarters, because we have an equal number of both, right? Well, what is 9 times 25 cents? That would be $2.25, right? Because 8 quarters is $2, another quarter is 25. We have 9 nickels. 9 times 0.05 is going to be equal to 45 cents, which gives you a grand total of $2.70, because I teach math and I can add. Hello. All right. Next question. Oh, look, we have another one of these boxes. When a certain number is placed in the empty box, the sum of the 3 numbers in each row, column, and diagonal is the same. What's the number in the center box? Well, we have this diagonal. And so in this diagonal, we have a center, and then we have a number that I don't know what it is. What shall I write when I don't know what the number is? How about n for number? So we have 5 plus c plus my n, c being the center, n being the number in the corner, and I don't know what that equals, but I'm trying to move my, there we go. There we go. Well, I also have this row here, which is 9 plus 7 plus my number. But I don't know what my number is. Well, if I have a number and the same number over here, they kind of cancel each other out. So that means 5 plus c is equal to 9 plus 7. Well, what is 9 plus 7? 16. So 5 plus c is equal to 16. What's the opposite of adding 5? Subtracting 5. So c is equal to 11. Equations make life much, much easier. The sooner we write them, the better. I actually talked to the elementary school teachers about doing that, and they thought I was crazy. But I swear it makes your life much better. All right, next question. Now this is the one problem that really gave me a long time. It took me a long time to do it, and I hope there's a better way. If you can come up with a better way for solving this one, please don't keep it a secret. All right, so t and v are in a 4-digit number where all the numbers are different, and t37v is divisible by 88 without a remainder. What digit is represented by t? Well, we need to break the 88 into its prime factors for starters. So we know that 11 goes into it, and I know I'm doing it backwards, but just follow me on this one. Times 8, right? And then 8 is 4 and 2, and then if you want to go farther, you can have 2s here. Point being, for 88 to go into this number, the divisibility rules of 2 and 8 have to apply, as well as the divisibility rules of 11, which for the life of me, I don't know. So we have blank, 3, 7, blank. And so I know that if 8 has to go into it, my choices are either 0, 2, 4, 6, or 8, right? And so the divisibility rules of 4 say that if I break it apart here, 4 has to go into 70-something. Well, 4 does not go into 70. 4 does go into 72. 4 does not go into 74. 4 does go into 76. So I've narrowed it down to 2 possibilities, 2 and 6. Now, to go a step further, for 8 to go into this number, 8 has to go into 7 and this blank, 70 blank. And 8 goes into 72, but not 76. So I can safely say that we have 372, but we don't know what that first number is. And this is where things get a little bit crazy. Cray-cray. I don't think that first part is really too hard to follow. But here is the crazy thing. We know that 11 also goes into this. So we have a blank 3, 7, 2. Now you're going to be introduced to my style of division here. This is another Framekeism. So we're going to work backwards, right? So for this thing to go in evenly, we know that 2 times 11 is 22. It's the only way to get this last number to be a 2. Well, if that is the case, that means we have had to carry a 2. So that means our remainder from this division here had to have a remainder of 2. Well, what would give us a remainder of 2? If this was 57, then 5 times 11 would be 55. It would give me the remainder of 2. So this would have to be 5. But, thank you, you too, sir. So then, continuing to work backwards, we have this 3, and so we had a remainder of 5, right? And so, if this was a 7, thank you, then we could say hello, Cody. My notes are a little sloppy here. So what would give us a remainder of 5 with a number of 3 here? And this is critically important. So, oh, it's 9, right? Because 9. So this is going to be 9. So then, this is an 8. So this has to be a 93, that's right. Because 88 times, 8 times 11 is 88. So 93 minus 88 gives me my remainder of 5. So therefore this has to be a 9. So my final answer is 9, 3, 7, 2.